Welcome everyone to today's webinar. We're excited to share with you. The topic today is Tableau maps and more. So a bunch of tips and tricks and all kinds of things working with geospatial data in Tableau. Uh, I'm excited to be joined by Bridget Cogley, and we'll do a little bit more formal introduction here in just a second. In fact, that second is now. So I am Joshua Milligan. I'm joined by Bridget Cogley. You can see our contact information there if you wish to reach out to us. We're also incredibly grateful to Technion Data Solutions. Not only are they our employer for both Bridget and I, but they graciously host these webinar series. And so we're excited to be part of that and to share with you via Technion today. In fact, I take it that everyone here is excited about data, especially as it comes to Tableau. Technion is a Tableau Gold partner, and so we've been working with Tableau for many years now. But Technion has a much broader scope than just Tableau, so you may be interested in additional webinar series that cover everything from data pipeline to data science, and all kinds of things data related. And of course, if you have any needs when it comes to data, feel free to reach out to Technion as well. Both Bridget and I are Tableau Zen Masters, which is an incredible honor from Tableau. We've been using Tableau, both of us, for years, and we're excited to do that and to help our clients and customers along the way. We're also excited to share with you today about Tableau geospatial data, so maps and all kinds of things related to geospatial data. A couple of housekeeping things. Yes, we're recording, so that recording will be available. It usually takes a day or two to process it and get it out there, but there's the link. You should also receive a follow-up email if you registered, so the link should be in that as well. Don't worry about trying to capture it here unless you want to. Also, there is a Q&A box somewhere. You should find that in your Zoom controls. If you are interested or have a question along the way, feel free to enter it in at any time. We'll usually try to reserve some time at the end to answer those questions, and we'll try to get to all of them, but no promises if there are a bunch. Although, feel free to reach out to us offline as well. So what are we going to look at today? Well, we've got a lot. I feel like we're going to fly, but it's going to be a lot of fun. I'm going to start out by talking about how to prep data and just do some simple geocoding. So we'll actually look at Tableau Prep, and you can think of how it applies to the platforms and tools that you use as well. But I love Tableau Prep, and we'll just talk about some tips and tricks for parsing out addresses and then doing some simple geocoding with that. We'll see a geospatial function or two and some practical uses behind that. And then a tip or trick or two, and then I'll conclude my my section, and Bridget's going to pick up, and I'm excited to see what she has to share. All I've seen so far are some screenshots, but they look amazing. She's going to talk about using formatting to improve map legibility. The things that she will share are beautiful, but also just amazingly simple in the way that you can understand them. Examples of using makeline, so another geospatial function with parameters, that'll be fun, and then some alternatives to density marks. So we'll get started here. I'm going to pull up just a list of addresses. No, not those. Let's try again. I'm going to try that one more time. Yeah, so let's say addresses that look like these. So if these are our addresses, you'll notice it's just a list of addresses, street, city, state, and zip, but nothing really easy. In fact, I did open the wrong file. You'll notice when I pull in the actual data, there's not even a comma before the state. So in fact, let's do that, and we'll make it a little bit easier to see. So I'm going to take a look at this here. Yeah, here we go. Here's the file I want, and I'm going to drop it onto Tableau Prep. Tableau Prep gives us a lot of capabilities when it comes to looking at these addresses. You'll notice that there is just the single field address here. That's a little bit unusual. Oftentimes you'll have additional data that goes along with the addresses. In fact, almost certainly you will, data that will make it more useful. If it's real estate data, you might have the selling price, the number of bedrooms, bathrooms, square footage, that sort of thing. If it's customer data, then you might note how many people are in the household, the ages. If it's you know, just you, so you'll think of how that relates to your data. I'm just going to focus on just the addresses for this example. And so, as I mentioned, the addresses here uh, are simply they're crammed all together. Uh, the address, city, state, zip, uh, they all show up in one field, no commas, no separation of any kind except for spaces. And these are fairly clean. A lot of times you'll see even messier data for addresses, but some of the techniques that we'll talk about will work even if the data is a little bit messier. So for example, I'm going to start out by noticing that it looks like all of these addresses end with state and zip code. And if I scroll through, that looks fairly consistent. And that gives me a nice starting place, because if I think about how I'm going to split this out, if I were to split on spaces, uh, that might work to get, you know, the street number at the beginning for most addresses. It's going to work to get the zip code and the state at the end. But everything else, I don't have any way of knowing. Does the street name, is it one word, 2 words, 3 words? Uh, the type of street, where is that going to be in this string? I don't know. And city names can, you know, they're usually 1 word, but not always. Here's North Richland Hills. That's 3 words. So I'm going to have some issues if I try to split on spaces, except that I think I can reliably do it for the last 2 positions. So I'm going to start there and do a custom split. And I'll tell it that I want to split on the spaces, and I want the last 2 to become fields. And I'll split, and we'll see what that gives us. And just as I had hoped, it does give us the state. In this case, all of these addresses are Texas addresses. And the zip codes look fairly clean. Adjust things like field names and values. So I just keep going. The address now, I'm going to simplify it because I've pulled out some of the data that I need. I'm going to remove that from the address so that I don't have to worry about it as I work with it. So I'm going to create a calculated field and just replace the address field with, I'm going to take out the state and the zip. So I'm going to replace within the string the state with a space after it, and then the zip code itself. And I'm going to replace that with just an empty string. And so when I do that, now I no longer see that show up. So that simplifies it a little bit, and now I can start to continue to work with this data. If I think about the next way that I want to split this out, I probably want to get the street number and name as one field, and then the city as the next field. So I'll end up with street, the city, and then I'll have state and zip. But as I noticed, there's no consistency in the number of words for a city or a street for that matter. What does look somewhat consistent is that everything is either square, court, lane, drive, way. So I see some of these that look a little bit circle, lane, road. So the abbreviations of the types of streets. So if I can use those, then I've got a way of potentially splitting it out. And what I'm going to do is I'm going to create another calculated field. I'm going to call this one just address parts. Specifically, it's the street and the city. But I'm going to replace every instance of drive or court or lane with whatever it was, drive, court, or lane, and then give it some sort of a character that I can split on. I like to use vertical bars. So to do this, I'm going to not use the normal replace function. I'm actually going to use the regular expression replace, and that's going to give me a lot of flexibility, as we'll see. So I'm going to do the address, and then the regular expression will kind of build this organically. But I noticed that everything, I don't want to accidentally replace any DR. You know, if it were to show up somewhere within the name of the city or the street, I don't want to replace it. I specifically want to get it if it has a space before it and a space after it. So we'll do DR. I'm going to put it in parentheses because I'm going to add more, and then another space after it. And I'm going to try to capture those. So drive or court or lane or street or road. There are probably more, and I'll come back to those. And I'm going to replace those with a space, because I'm not going to capture the space here. So by putting in parentheses here, I'm only going to capture that part, but I want to put that part back. So if I put $1, that tells it put the drive, court, lane, street, or whatever it is back, and then follow it up with a vertical bar. And let's save this and see if I got it right. Yeah, so that's looking pretty good. It actually did put a vertical bar after each one of those: court, street, drive, road, and everything that I can see there looks good. I'm going to keep going down through here and see if I see any that don't. Oh, avenue. Okay, so Tableau Prep makes it so that I can be a little bit organic in the way that I work with it. I can go back and edit that calculation and just add in avenue as another possibility. And now avenue has a pipe after it. Let's take a look and see if there are any more. I could spend quite a bit of time just manually kind of going through and looking to see if there's any that I've missed. Everything's looking pretty good, but I suspect there are probably a few abbreviations that I haven't thought of. So to check that a lot more quickly than I can go through it, I'm just going to create a quick calculated field and ask the question, does it contain the vertical bar? And so we'll just get a true or false based on whether it contains a vertical bar. And sure enough, it looks like most of them do, about 86%, but I still have a few rows here that don't. So if I click on that, now I can start to see CRK, creek, circle, trail, okay, way. So I've got a few here that I'm gonna go back and edit this calculation again. So creek, circle, trail, way. I'll save that and then come back here. And now my false bar is getting shorter and shorter. Okay, boulevard, terrace, place, square. And so hopefully it doesn't take too long, but terrace, place, and square. But I'll keep going back and forth here until I've cleaned it all up. And there it is. Everything is now true. So I no longer need this field. I'll remove that. And now I'm ready to take these address parts and split them out. So I'll split these out with a custom split. and we'll do the bar, and we'll just say, let's take those first two fields. It should always be two, but I like to have some control over what ends up to be the result. So now, if I look through it, I've got the street names and numbers. That's fine. I could split out the numbers if I wanted to. I don't really care to at this point. I could even split out the type if I wanted to. But I don't, because my ultimate goal here is to take all of these little pieces, the street, the city, the state, the zip, and to use those to get a latitude and longitude. I'm going to remove that address parts field, the address field. And what I found, there are lots of ways that you can geocode addresses. Some you could even feed them in the way that they were here before I went through this whole process. But the way that I found, which is simple and free, which is nice, but a little bit limited in terms of the number, I think the limit is 10,000, is that I can go to census.gov and upload a file that consists just of these, although the first thing it also needs is a row number. So Tableau Prep allows me to add that. If this was a real data set, I probably had a unique identifier of some kind that I would use to match back up with my data. But here, I'm going to just add the row number. So I'm going to partition it across the entire data set. I do have a field that identifies the entire data set. Everything in the data is Texas, so I'll partition it by the state. Then I have to order it. So I'll order by, this one's a little bit arbitrary. It's going to be a unique row number, but I'll order it by street just for fun. There's a lot of streets, and I want the row number itself. So this will give me a row, and that's just so when I upload the data to census.gov, this is the right structure of the output file that it likes. So I'll take that to an output. It wants it as a CSV, and it wants me to, yeah, here, addresses to geocode. I already have it. I'll replace it and output it. And sure enough, I'll go ahead and replace it. It goes really fast. I only had about 500 addresses or even less. So then I would take that to census.gov, has a nice geocoder, and it allows me to upload a batch of files here. I can choose my file and addresses to geocode. I'll select that and say get results. Now it takes it a while, so I'm going to do the quick switch over to pull it out of the oven, and let's take a look at what it would look like after the fact. It's going to look something like this. So it comes back, you'll notice the rows aren't necessarily in order, that's fine. It also doesn't give me a header, but that's okay, I'll create my own header. And we'll call this row. This is my old address. This is the one that I gave it. So you'll see it's all comma separated by each part of the address. And then it tells me whether it found a matched or not. So some things didn't match, some things did match. It'll be interesting to see how many. It tells me the match type. Was it exact? Was it close? Was it not at all? Gives me the new address. And then the parts that I really care about are right here, latitude and longitude. Although interestingly, as I discovered, it actually comes back a little bit reverse than I expected, longitude and then latitude. And the rest of this is confidence intervals and all kinds of other interesting things related to the geocoding. I'm not going to worry about that right now, but I will save this file and we'll take it to Tableau. Oh, here it is. So it came back now, and that file would look very similar. So I'll open up Tableau and then pull in our geocoded results right now to take a look at what that might look like. You'll see it has my old address, my new address, my longitude and latitude, and then some of these fields that I don't care as much about. So I'll get rid of those. We'll hide those. But this one, I am going to have to do a little bit of additional work on it here, and I can do it right here in Tableau, but I'm going to split this out. We'll do a custom split and just do the first two fields based on the comma. And that will give me my longitude and my latitude. Now you'll notice because the first field was a string, Tableau is still treating these as strings, but I'm going to tell it no, these are numeric decimals. And notice that that even as I made a change, it automatically picked up the geographic use of that field. It's longitude. I could set that as well if I needed to, the geographic role. I could tell that this one is latitude. Then I no longer need this field. I can hide that one. I don't even really care about old address. And I don't really care that it's new address. I'll just call it address. Now I can go and start to look at this data, and I can start to ask some questions, you know, in terms of how many matched or didn't match. So if I look here, I see that there are matches, no matches, and even some ties. And I might ask how many. Now, if you're using an older version of Tableau, you're used to seeing a number of records field. The newer versions of Tableau will give you the name of the table, in this case the file, and count. That's because of the new Tableau data model. If you're interested in that, our last webinar in the Tableau series was all about the Tableau data model, so you can go check out the recording there. But I look at that and I see that the vast majority of them matched. Some didn't, some came up with a tie. I could look at that in terms of a percentage, and I got about an 84% match. So for my purposes today, that's good enough. But there may be times when you need more, and you may need to go back and find out why didn't they match. All right, so a new sheet. And now the fun part, let's take a look at where it located these, so latitude and longitude. And I look around and I see all the little dots, but it's hard for me to tell where this is on the map. I could zoom in and out, maybe that would help, but it also might help just to get a bearing by changing the background maps. So Tableau has recently added a lot of possibilities, but in this case, streets might be the most useful for me to sort of get an understanding of where these are. So these are all in the Dallas and Fort Worth Metroplex, and a few scattered elsewhere. Now, streets tends to be a very it's a great view, but it also tends to obscure some of the data potentially because the names and streets are all pretty dark. So sometimes what I like to do is go to my map layers from the menu and give it just a bit of washout so that the data shows up even a little bit better. And you can decide how much you like or what helps you communicate things the best. I also sometimes like to go to the color on the marks and especially give them a little bit of a border so that they pop out even more, maybe a little bit of reduction of opacity so that I can see if there are some overlap. And so now I've got a really nice data set to work with. And then what I might do is I might take my geocoded data set. Now I know the location of these addresses in terms of latitude and longitude, but now I'll take that back to my original data set, maybe join that back in with Tableau Prep or something else. And now I can start to ask even additional questions. So here's latitude, longitude, place address on there. Once again, I'll go to my my maps and set it to streets. And one thing that that I might start to look at is, what are these? Turns out most of these are houses. A few of them, 2 of them, in fact, are hospitals. And so I've got hospitals, I've got residences, or potentially places where patients are. And now I might start to ask even additional questions. I might say, how closer are these patients to the hospitals? Which is the closest hospital? What if I were to ask, how many patients or how many patient households fall within a given radius of a hospital? Well, that could be a very interesting question, and that's something that I can do even here within Tableau. So I might create a calculated field, and I'm going to look at the geospatial functions, or the spatial functions. I've got 4 of them, so Bridget's going to look at some as well, but the 2 that I'm going to look at are these 2, buffer and make point. Make point just creates a spatial object based on a set of coordinates. In this case, latitude and longitude are what I have. So I'm going to use that, but I'm going to use a buffer as well to draw a radius around the hospitals. So in order to do that, I'm just going to start out by saying this only applies to hospitals. So if the type is a hospital, then we'll make that buffer. So buffer, first thing it wants is a geometry, and a geometry object is something like a point or a line or a buffer. So in this case, I'm going to make a buffer around my points. And I have the latitude and I have the longitude. And then I give it a number as well as a units. So maybe 15 miles. So I'm going to put MI in open quotes. You can do meters. There may be even some other things that you would find in the documentation. But let's go ahead and say OK there. And what I would find here, let's rename that as well. That's my hospital radius. So how do I use this? I see that it has a geographic role of some kind. It's a geographic field because it's returning a spatial object. Well, the way that I would use this is to place it here on the marks card, but I can't use my latitude and longitude. Instead, I'm going to use the ones that Tableau generates. So latitude, longitude, and now I see that it's drawing this nice buffer around the areas where those 2 hospitals were. I might reduce the opacity of that even more. But how do I get to see the patient households that fall inside or outside of those buffers? Well, one easy way to do it is to create a dual axis map. So I'm going to copy by holding Control on latitude or longitude. And now on one of these, instead of using this hospital radius as the geographic information for Tableau, I'm going to take that out. And instead, I'm going to take my latitude and longitude that defines the location of each house and place those here. So you can see now those show up nicely on this part of the map. These show up here, and I could say, let's make that a dual axis. Now I can see each household. I might even take the opacity back up here, but now I can see each household that falls inside or outside the radius. And you might say, well, you can kind of see it, but how do you know for sure? Or how do you count them? Or how do you do some even more complex analysis on these? Is there a way for Tableau to know what falls inside or outside those radiuses? And I would say yes. And now I'm sure Tableau will make it even easier in the future. They keep adding geospatial functions. But even now, I can do that by editing my data source and using what's called a spatial join. So my data source right now is really simple. It's just this hospitals and houses CSV file. I'm going to double click to go into the physical layer where I can do a spatial join, and I'm going to join it to itself. And I'm going to join it on a spatial object. Now I'm going to have to create my spatial object here. Some databases and of course spatial files would have spatial objects already, but here I'm going to join it, and I'm going to use the same calculations. So if it's a hospital, then we'll make a buffer around that point, latitude, longitude, 15-mile radius. And what I want to do is I want to say we'll what have I missed? Oh, yeah, I guess it would like it then. What we'll do is we'll say, I want to find out all the points, so latitude and longitude, but I need to create a point based on that. So make point, latitude, longitude. You'll notice the names are from this second file. And the join type is not going to be equals, but rather intersects. So I'm going to say where do those points intersect? Now if I do an inner join, it's only going to be the houses that fall inside the radius. So if that's the kind of analysis I want, then that's great. Otherwise I might explore some other options, and like doing a right join. And now you'll notice as I scroll down, all of the hospitals are matching with all of the houses except for any houses that don't intersect. The hospital information is null, and I can use that. So I'm going to close this out and come back to our view. Now it's a little bit messed up because what I need, let's do one other thing to make this a little bit easier. So I'm going to come back to my data source. Let's actually just call this hospital and call this one house. Now when I come back here, it'll be a little bit more obvious. So Tableau very nicely tells me what relates to the hospital table, what relates to the house table. Well, here's the problem. The only two, the latitude and longitude, that relates to the hospitals. That's why I'm only seeing two. So let's take our houses now. So this one's fine, but let's take our latitude and longitude here. Latitude, longitude, and let's take our address, and we'll remove type here. But you'll notice now I get all the houses, I get those buffers, and now I can even here type or any of these fields will tell me it will tell me whether it came or not, because you'll remember all of these fields for hospital, they are null in the case that the house was outside. So I can just create a calculated field to say, is it in the radius? And we'll just check for whether or not one of these fields is null. I'll use row. Really wouldn't matter. And I can take that one, place that on color, and now notice that I can very easily tell which ones fell within the radius, which ones fell outside. I've got a nice dimension that I can start to use to split that apart and do all kinds of different analysis. And so that could be very useful as you go on. I'm going to turn it over to Bridget at this point, because she's going to pick up from here and show what else is possible, and I'm excited to see what she has to share.
Perfect. Well, thank you very much. I'm going to go ahead and jump right into the same data set. So this is the same data set that Joshua used. And so what I've got here is a little bit different. I went ahead and I organized out the information into folders. So we've got the default information. I went ahead and added a calculation to call out houses, But what I'm going to start doing first is I'm going to take a different approach from Joshua on how I format my map. So one thing I'm going to do is I'm going to get rid of all the lines. Not a fan of the lines, and then this will come into play here in a few moments. So this becomes important. The other thing I'm going to do is I'm going to go right to this worksheet. This is, to me, one of the coolest features Tableau gave me. I begged them for years for it, and they told me it wasn't possible, and then they dropped it stealthily, like, hey, here's this awesome feature. One of the cool things is that Tableau is now powered by Mapbox Maps, and I think that's really neat because what it does is it gives us access to a number of things. But one thing I'm going to do is I'm actually going to knock out the base, knock out the land cover. I'll keep my coastline just in case. I've also got access to streets right here. I'm zoomed in enough that it'll show. And then I'm also going to favor some of the light features. So rather than the dark county and dark state and dark everything, I'm going to jump things down a bit. If I want, I can highlight out county borders. I'm not going to do that because part of what I'm trying to do is really knock out the noise. And then just for my own sake, I'm going to go with perhaps a little bit more of a branded color. And I'm going to take a different approach as well. I'm going to have no border. And then I'll still have some of the transparency. So I'll keep the opacity at 80%. But what this allows me to do is it really makes the map very, very clean. So you'll see this style over and over where I've knocked things out. And there's a hidden feature where, because the map is now transparent, if I want to put items in the background, I can. So if I want to put circles or decor, I can certainly do so. And so what I want to do is take that analysis that Joshua started and take it perhaps a little bit further. And one of the things I noticed is that primary hospitals horrifically overutilized. I've got 80% of the homes in the area that are closer to the primary. And so one of the first things I did is I took his geopoints, and instead of using points, I decided to use makeline. I wanted to understand paths. I wanted to see kind of how people traveled into this. And so the way to do that is I've actually got a couple different calculations happening here. So the first thing I did is I called out my hospitals, but then I made a primary hospital. And one thing I wanted to do was not join the data. So I actually went ahead and I did this as a fixed calculation. So I've got this information here. It's fixed. It'll carry all the way through the data set. And so that way I can very easily compare and use this throughout the entire data set. So that's a way to circumvent some of the data shaping. So that's what a lot of these calculations are. I will warn you, the more calculations you throw into Tableau, it can become a problem with a lot of data later on. So that's just one thing to be cognizant of, is really that line between what can I do in Tableau versus at what point do I push it back to the database or the data prep flow. So with this, what I did is I used makeline. And makeline is great if you've got airports, but it's also great if you want a bird's eye view of travel. And so what I've got here is I've got two different calculations. One calculation is distance. This is a new calculation. So if I want, and I'll feature this one a little bit later as well, but what I did is I compared the distance between my hospital, the primary hospital and the secondary hospital, and I said, whichever one is closest, make a line to that one. And so I will also share this workbook as well so you can go through and really dissect this. But the key part is I'm really trying to make use of distance, but then once I've got the 2 points, I make a line. And then I've just added extra complexity with the if then. So that gives me this. And what it does is it provides me a high-level glance. I can really quickly and easily see just how few paths my secondary hospital has. I've also hit the point home just with some extra visuals to really let people know I've got 80% of homes potentially going to this one hospital. That's definitely a concern. So what I'm going to start doing is I'm going to make a few different goals. And one of my goals is I want to start improving the distribution or the load between the hospitals. And so I may shift my marketing. And so we can see kind of prior to that, I'm at 80%. If I start saying, okay, well, you know, maybe somebody will drive an extra 12 miles or an extra 10 miles. And so I can start kind of scenario testing and playing with this. This gives me real-time analysis and scenario testing to see, okay, if there are people willing to drive an extra 15 miles, they'll make it to this secondary hospital. I don't think 15 is reasonable, so I'm going to go with 12. And that puts kind of my long distance haulers more likely to go to this local hospital, although maybe, just maybe, they'll be willing to take the extra 15. How did I do that? So part of this really goes to setting the path of pre-forma and pro-forma. And this is a definite passionate area of mine where, again, you can see some calculations. You can see where I've got this distance calculation kind of come up here. So you can see I've got the distance between any geopoint at the road level and then my primary hospital. Again, you can see that this is a fixed statement. It's very, very hard to see it, but I do have those curly brackets in there. And so then I've also got it done by miles. You see I chose to spell out my miles, but you can also use the short version that Joshua used. Going into the pro forma, what I did with my make line is I edited it. So now I said, okay, you know what, I'm going to take this same calculation, but let's go ahead and throw a parameter in there. And we'll either take off the amount of miles, or what we'll do is we'll add it over to the other side. So you can see where I've kind of played with this, just so I can see, are people maybe, if they don't mind an extra little bit of a drive, would they be willing to come to this hospital, particularly if wait times are lower. So from a marketing and communication standpoint, I may continue to play with that. We'll say my department settled on 12 because we felt that was the most realistic. That's the one that gets us a pretty decent value, but then it also allows us to get kind of, it's more likely versus we may even push it to the 15. That would be an ideal balance, but we may not be able to handle it from a hospital standpoint. One of the next things I did, and I run into this a lot when I'm playing with density marks, I absolutely love them as a feature. And density marks are great. What they allow you to do is pull out a shapefile. You can select them right from the marks, and then you can kind of get a feel for where your areas are saturated. They are superb. Now, one challenge I've had with them is when I throw them at millions and millions of rows, they really, really start to struggle. So how do I get a density plot without necessarily overloading my system with millions and millions of data? Because the one thing to note with these density plots is they are not aggregated. They are visually aggregated, but they are not at the row level aggregated. So when I look down here and I look at my marks, which I've got something over, unfortunately, I can see that I've got 347 marks in this data set. Not a big deal, but when I get to millions and millions of rows, it definitely hurts. So if I go to this other one where I've started to play with aggregating and rolling up the data, you can see I'm down to 38 marks with the same data set. How did I do that? So we'll get to one of the things I've done. You'll see I've got this pro forma parameter, and I can also see that I've played with granularity. So if I go to where I've called it my cropping, it's a surprisingly easy solution and yet very, very elegant. I've taken each of my coordinates and I've simply rounded down the value. And what this does is it gives me a level of aggregation that still gives me a good amount of spatial awareness. And so that way I can continue to explore and understand, are there better ways of maybe marketing to hospitals, positioning hospitals, and I may find opportunity maybe in some of these lower areas where I may want to potentially either explore adding a third hospital or a clinic or something of that sort. So that's another way to get the same effect as a density plot, but with perhaps a little bit more load-bearing tolerance. And then I can expose that to my end user, so if they want to dig down into the granularity, they can. The other fun part about this, I've got the visual aggregation here, but I've actually got true aggregation here. I can continue to allow drill down and exposure into these different areas. So you can see I'm kind of working through my goals. The final piece is really figuring out, so taking a little bit of what Joshua did before, but altering it a bit. So you can see where I've got selected and non. So I've got these different areas, and using set actions, I can allow people to kind of filter in on these items. You'll notice I've got two effects going on here. I've got the distance calculation applied on this particular worksheet. So you can see here where I've went ahead and created kind of that buffering zone. So I've said, is this in the buffer zone? And so what I've done here is I've just said, if the miles from selected are equal to the parameter that I'm using, mark it as -1. Otherwise, give me the exact miles. And what this allows me to do is do a little bit of hacky dual encoding. So you can see for one, I've got the actual distance tabulated, so you can really see how far they are. But if I go to the other, you can see that I've got my buffer zone circle, again, really making use of this dual axis. You can see I've got these items focused in. I went ahead and used that calculation, so my negative is called out in a very bright color. They're brought into focus, but then you can get a sense for how far things still are from the hospital. Again, that really makes use of those fixed calculations, so really fixing my hospitals so that they go down through the data rows. And so this gives me a way to very visually and easily show information. But then if I go back into my dashboard and I'm starting to plan for, I'm going to build out a brand new hospital, and I don't want it to land where my other new hospitals are, I can see that if I move, down to this lower area, I have a chance to maybe catch a new audience that isn't fully captured, but that I can also not overlap like I am now and further unburden my primary hospital. So this is a great way to use spatial analytics. You'll also notice that, yes, I am actually using multiple maps. And so don't hesitate to use multiple maps in your visualizations. They can certainly be powerful. You can also use set actions to create those UI experiences so that we're really having a very natural clicking experience and exploring what works. The final version of this, you'll notice that this is an example of mapping and really knocking out the map, going very, very custom. And so I'll kind of highlight that this uses the dark map format. And so you can see I've got the dark map format. I haven't worried about washout. You'll notice I knocked out a bunch of stuff, but then you'll also notice again, a lot of that dual axis just to provide clarity. So using region, and you'll notice too, I just want to call this out, that Tableau allows you to create your own custom geography. So you've got geographic role. I've said create from state or province. If I wanted to do it from postal code or city, I could certainly do that. If I wanted to map all the states or all the cities named Columbus, I could potentially make a unique Columbus zone. But you can see how I've got my regions. They're very, very tidy. It provides additional clarity. And then I've got my different points mapped on it. I can also call out how many potential donors live within a region. And that gives me an idea of targeting. The final piece is I've went ahead and used a mini map. And so this again is just one of those ways to provide clarity. Here's the trick. So with this, one of the things I did is I made sure to crop it down to zip code just to make sure that it zooms in enough, because Tableau really likes those data points so that it knows where to zoom into and not over zoom or under zoom. So you'll see that that dual axis allows me to say, hey, zoom into this zip code. That gives me enough clarity to know what road this thing falls on. So this is a great way to build UI experiences and help people navigate through what you've got. The final fun part, again, this is more fun with sets and parameters, color coding. I cannot stress enough how much I love to use color coding to really highlight and make things clear so that as my workers are going through a particular script, they know that, okay, this script is for, I'm trying to get a certain amount from people versus this is a named sponsorship and the donation amount is significantly higher. So this gives you an idea of how you knock out the maps, you can see how they play within the primary space, how much cleaner they look, and how much more information you get as well. So with that, I will move to questions.
All right, we had a few questions. One question had to do with, or a couple with Tableau Prep, whether there was an index function or how to compute that row once again. So yeah, let me share my screen and I will, I'll take a look at that here. So there is no index function, at least not yet in Tableau Prep. But a relatively new function is the ability to create a row number as well as rank items within Tableau. It's a little bit of a complex uh, kind of syntax, but if you look at it, these functions are called analytic functions, and you'll see there are quite a few rank functions. They all make use of partition and order by, and then ascending and descending for some of these as well. And then row number here at the end is the one we used. And so the idea is that you tell it, you give it the partition. And so partition is kind of what you would think of with table calculations in Tableau. In Tableau proper, except that what you're doing is you're just telling it within a certain partition. For example, if I were to tell it the zip code was the partition, it would create unique row numbers for each zip code, but it would start over for each zip code. So the way that I usually write these is to start with partition. It's going to add the curly braces as needed, and then I tell it how to partition it. So maybe by zip, and then a colon, because now I also have to tell it how to order by. And so order by tells it just what order it goes in, and so if it's a row number, for example, then each the row numbers would happen according to the value of city, for example, or according to the value of street, or according to the value of state even. I could use that, and it's still going to be a unique row number. It's just going to use those as some guideposts for ordering. So it doesn't, for row number at least, it definitely doesn't really matter. Obviously for rank, it would matter more so, because that's going to tell it what defines that rank. So order by, and then which function I want, rank or row number, are the two real options here. So row number is what I use to get that row number. So I can call this row 2, and then you have some options with rank as well. But yeah, these are incredibly nice to look at. So yeah, you'll see here I actually have some duplicates of row number, because I told it the partition was zip code, but you'll see each zip code is only going to have one row number 1. And if I look at each zip code, you'll see rows 1 through 8, rows 1 through 11. That one just has row 1. So lots of cool ways that you can use those functions within Tableau Prep, and they're going to continue to build that out, and you'll be able to use more and more analytic functions in the future. There's a question about regular expressions. So any good resources for regular expressions? That's a great question. Bridget, you may have some ideas, because the way that I've kind of picked them up is just to run into cases where I've needed to use them, and then Google and figure out kind of how to build them. There are some great testing tools online, so you can use these. You might, for example, take your list of, let's see if we've got, yeah, so you might take your data, or at least some sample data, plug that in, and then start to use that to see, okay, what things start to match if I'm looking for them. And
one of the tools I like, and I think I linked to it in that question, is the regexer tool. And what that does is it gives you a little bit more guidance. But again, a lot of it is definitely a lot like you, where kind of trial and error. And, you know, unfortunately, it really is one of those things. The more you practice, the better you get at it.
yeah, that's been my experience as well. I'm sure there are books, YouTube videos, and everything, but I just personally don't have the experience to know which ones to recommend.
Yeah, I would definitely say the regexr one I linked to. So it's regexr.com, and that's the one I go to. It just gives you a little bit more examples, a little bit more guidance.
Okay, perfect. Let's see, Bridget, do you see any other questions? I think that there were. Oh yeah, here we go. Yeah, I'm still getting used to the Zoom controls. So there's a question here, what version of Tableau does this functionality use? So we've used a lot of different functions within Tableau, and some of them are relatively new, some of them have been around for a while. The geospatial functions are relatively new, so Bridget, you may remember exactly, but I'm thinking 2019.2,
Late,
somewhere
yeah.
in there.
I feel like late 2019.2, and then I feel like there was definitely a spell where you could almost count on at least a couple geo features in every new version.
Yeah, so definitely later versions, if you're using an early 2019 or anything before that, some of these features would not be available, especially the geo functions. But even before that, Tableau had a broad range of capability. I mean, if you had anything that it recognized as a geospatial role, zip codes, even airports, congressional districts, counties, cities, states, zips, all of that, it has its own internal database where it will be able to visualize that.
So one question I'm seeing is there was a question around, I was under the impression there was a native capability in map view to draw a circle buffer around a point. Also thought it would natively allow you to count points inside the circle. Do you want to show, I think it's a filter.
Is it the filter, or is it, there is a radial selection as well, which is kind of what I was thinking
Mm-hmm.
with that. So I can do that, and it does actually show a the radius itself. And then if I make that selection, it will definitely tell me how many marks I have selected.
So another question I see is, what utility would you recommend for drawing polygons on your map? I would say there's a number of spatial programs. So QGIS is a free one. I've even gone into Google. So there's a My Google Maps, and you can go in and actually do kind of your own really quick and dirty KML files. And I've done that to great effect as well. And then, I mean, of course, you can definitely go into tools like Alteryx. And then there's a lot you can do just with custom geocoding right in Tableau.
All right, well, very cool. I don't see any other questions right off.
I would say one other one is drive time. I don't know of doing drive time yet. I think there's possibly a way, if you go download roads data and you have access to the rough speed limits, you could possibly do it. But again, that I would say that's definitely going deeper into the weeds of what it could be done.
That there are possibilities there, and I know some of our colleagues who are more versed with those tools would be able to help with that. Yeah, very cool.
Well, thank you so much. I've uploaded my workbook up to Tableau Public, so you're welcome to go and download that and play with the calculations.
Awesome. I will likewise have mine up there shortly, and so yeah, it should be really fun to play with. I especially look forward to looking at yours, Bridget. All right, well, thank you so much for joining us today. We've, as always, we've enjoyed it, and we count ourselves very privileged to have you with us as we do these month by month. So we look forward to next time. Let us know if there's anything we can do in the meantime. See you then.